Hello, good morning viewers. The title of this tutorial is Understanding Alternate Segment Theorem. To understand this theorem clearly, let us define some terminologies. First of all, we need a cycle. I have already constructed my cycle. Any part of a cycle is called circumference. So this is circumference. We also need a tangent. A tangent is any line that touches the circumference at exactly one point. So this is a tangent. Let me label it as AB. And this is a tangent. We also need a chord. A chord is a line that passes through a cycle, touching the circumference at 2 points. So it could either be a diameter, any other line. Example, this is a chord. Also, we need to define an arc. An arc is any portion of the circumference. So from this point, let me call this C, let me call this D. From C to D, this curve right here is an arc. Also, C to D in this other direction is an arc. So how can we define a segment? A segment is that area bounded by the chord and the arc. So you can see we have an arc CD and we have a chord CD. So this portion right here is a segment. This portion to the top is also a segment. It's also a segment. But what differentiates the two is that this is minor segment and this is the major segment. We're moving. We want to define that angle formed by the chord and the tangent. Therefore, one of the legs of the chord must touch that point where the tangent touches the circumference at exactly 1 point. So we want to construct a chord that will touch this point where the tangent touches the cycle. So let me clear all these things and draw a nice chord. So I have just cleared everything. We want to draw a chord that will touch this point, and let me call it C. So this can be a chord. This is a chord. All right. What you should observe here is that this chord and a tangent form an angle here. And I can call it beta. Okay, now we are going to subtend an angle to the circumference from end to end of this chord. So this is what I mean. It could be from anywhere. So this angle formed by the chord to the circumference is also the same as beta. So what alternate segment theorem is telling us is that that angle formed by the chord and the tangent is exactly equal to that angle subtended by that chord to the circumference. You can see the chord CD subtend an angle to the circumference. It must be exactly equal to that angle formed by that chord and the tangent. That is just the theory about it. And even this one at the back, because let me call this one E. EC or CE is a chord and it subtend an angle D to the circumference. Therefore, if this is alpha, this must be alpha. That is what alternate segment theorem is telling us. But should we prove it? Yes, I think it is necessary. All right. Let's assume this is the center of the cycle. We want to construct a radius that will touch that point of contact between the circumference and the tangent, which is point C. If we should extend the radius to the top, it becomes a diameter. So let me extend it to the top. Let me call this one F. Now we are going to connect F and D together. Okay, let's go back to the cycle theorem. In cycle theorem, one of the properties of chord is that if a diameter, because a diameter is also a chord, subtends an angle to the circumference, the angle formed is 90 degrees. Therefore, this angle right here, degrees. If this angle is 90 degrees, remember that this angle also is beta for two reasons. One, because all angles that are subtended to the circumference from the same chord are equal. So if this is beta, or if this is beta, this must be equal to beta. And if this is 90 degrees, you can see that this is a right angle triangle. This angle added up to beta will give us 90. Therefore, this angle will be 90 degrees minus beta. Let's assume we don't know this angle. Let's call it a name X. Remember that a radius and a tangent form a right angle. Therefore, this angle right here is 90 degrees. And if you should add X and 90 minus beta, you shall obtain 90 degrees. So let's see whether we're going to get beta. 90 degrees minus beta plus X. This is equal to 90 degrees. Let us take everything to the right, leaving only X because we want to define X. X will be equal to 90 degrees to the right minus this 90 if it crosses over. If negative beta crosses over, it becomes positive. You can see that this cancels this. Finally, X equal to beta. This shows that this angle subtended by the chord and the tangent is equal to beta, which is exactly equal to this, and hence proved. So this is how to define alternate segment theorem. And this is all I have for you today. Thank you for watching. Do share to your learning colleagues and don't forget to subscribe to my YouTube channel for more exciting videos. Bye bye.